So let's discuss what a quadratic equation is. So a quadratic equation in the variable x is an equation that can be written down in this form. Ax plus b plus c is equal to 0. Now a, b and c here are real numbers, they're real constants. And a is not equal to 0. This is very important because if a is equal to 0, that would mean that this equation is just bx plus c, and that is a linear equation. That is not a quadratic equation. So basically another name for a quadratic equation is x is a second degree polynomial in x, as uh, the highest power of x in this equation is 2. So this is an example of a quadratic equation. Over here the value of a is 1, b is -7, and c is 10. This is a. Similarly here the value of a here is 6, the value of b here is 1, and the value of c here is -15. So there are three ways to solve quadratic equations. One by factorization, the second is by completing square method, and the third is by applying the quadratic formula. We'll discuss these later. Now let's see how to solve a quadratic equation using factorization. Now over here we must basically convert this a quadratic equation into a form similar to this here. When you expand x minus 2 multiplied by x minus 4, it will basically give you a quadratic equation. We must convert a quadratic equation into this form to get two values for x. So like over here, x minus 2 and x minus 4 is equal to 0. So over here, either x minus 2 is equal to 0 or x minus 4 is equal to 0. And by that, you can actually solve for the values of x. So here the value of x is 2 and here the value of x is 4. Simple. So let's just say we have this quadratic equation here. We must convert this into this. Now, how do we do that? Well, over here the value of a is 1 and the value of c is 10. So what we'll do here is basically a multiplied by c is equal to 10. And the value of b here is -7. So what you must remember is the value of a multiplied by c and the value of b. And so you must find two numbers that when you multiply them, they'll give you 10. And when you'll add the same numbers, they'll give you -7. So like over here, we have this 10 here, AC. So you can multiply 1 and 10 to get this, or you can multiply -1 and -10 to get this. You can multiply 2 and 5 to get this, and you can multiply -2 and -5 to get this. And these are the only numbers. These are the only combinations that will give you 10. So over here you can clearly see that when you add -2 and -5, it will give you -7. So we'll just use basically this combination to factorize this polynomial. So what you'll do here is, how do you get this? Well, as you remember, we have -2 and -5. So what you'll do here is you'll put the x squared, the term of x squared as it is, and you will just uh, basically divide the -7 into -2 and -5. So it will basically become -2x and -5x. As you know, -2x minus 5x just becomes -7x. But we'll use basically this combination over here. And then you'll put the c as it is. And now, when you factorize this, basically this becomes x into x minus 2 and -5 into x minus 2. Now, as you can see, you have x minus 2 here and x minus 2 here. This is very important. These must be same. So x minus 2 and x minus 2, we'll put them in one bracket over here. And these two terms will go in another bracket. And that is how you factorize that quadratic equation. We have achieved this now. Now, either the value of x minus 2 is equal to 0, so x is equal to 2, or the value of x minus 5 is equal to 0, so x is equal to 5. So now we have two values for x, and this is the solution set. So let's see how to solve a quadratic equation using the completing square method. Now, sometimes quadratic equations are not easily factorable. As you can see here in this example, we have minus 437. This is not easily factorable. So we will use the completing square method here. Now there are certain steps we must follow for the completing square method. First off, you must remember that the coefficient of x square must be 1. Over here, it is our sheer luck that it is already 1, but if it was not 1, you would have had to divide the entire equation by that number so that you can have the coefficient of x square as 1. Now, the second thing to remember is that you will divide the exponent, you will divide the coefficient of the x term by 2, as we've done here. And you'll take 2 outside so that it cancels out. So you'll put this in this form, and then you'll take the c term here and you'll put it on the right hand side. So minus 437 becomes plus 437. So after doing those three things, you get this here. And now what you'll do is you'll add whatever you'll get here. You'll take its square and then you'll add it on both the right hand side and the left hand side. So you'll get this. As you know, 4 over 2 becomes 2, and you'll take the whole square, and that becomes basically this. It becomes 2 square. So you'll add 2 square on both sides. And now, as you know, what you'll do here is you'll take this term and you'll take this term, and then you'll put whatever this sign is between them. So x plus 2, and then you'll take the whole square of that number, whatever that results in. So x plus 2 whole square. If this was x minus 4x plus 2 square, this would have been x minus 2 whole square. And then you will put it equal to whatever this results in, and that results in 441 in this case. So you'll take square root on both sides to get x plus 2 is equal to plus minus 21. So this will result in x is equal to 19 or x is equal to minus 23, depending on if you take 21 as positive or if you take 21 as negative. So if you take 21 as positive, it will give you 21 minus 2, which is equal to 19. Or if you take 21 as negative, that will give you minus 21 minus 2, which is equal to minus 23. That's it. So let's see how you'll solve a quadratic equation using the quadratic formula. So this is the most foolproof way of solving a quadratic equation. And basically, you have a standard quadratic equation form. And basically, you'll have to use this simple formula to get the values of x. Now, this is called the quadratic formula, and we have this example here. So you can see that the value of a here is 6, the value of b here is plus 1, and the value of c here is minus 15. So you have these three values, and basically you'll plug these values into this equation here to get the values of x. So this is what you'll get when you plug in minus b plus minus under root b square minus 4ac divided by 2a. And so you get minus 1 plus minus under root 361 divided by 12. So this becomes minus 1 plus minus 19 over 12. So you'll get two values of x depending on whether you take 19 as positive or if you take 19 as negative. So if you take 19 as positive, you'll get x is equal to 3 by 2, or if you take 19 as negative, you get x is equal to minus 5 by 3, and that's how you use the quadratic formula. Now, it's not necessary that you'll always have an equation in its quadratic form. In most cases, you'll have to convert an equation into its quadratic form to get the values you desire. So you have this equation here. Now see that the highest order of x is 4. It's not 2, so this is not a quadratic equation. So you must convert this into a quadratic equation. What you'll do is, you'll basically see this here, and you'll see this here. You must convert the first term, the highest order term, into a quadratic form. So this becomes x power 4 becomes x to the power 2 raised to the power 2. So this is a quadratic form of this. If this was, say, x to the power 8, you would have taken x to the power 4 whole power 2. Now, you'll put y in place of x square in this entire equation. So x square is equal to y. And when you plug in y into this equation, you get y square minus 6y plus 8. And this is indeed a quadratic equation. Now you'll solve for y by using the factorization method. We've discussed that earlier. And by using the factorization method, you get this when it's simplified. So either y minus 4 is equal to 0 or y minus 2 is equal to 0. So you get two values of y which are 4 and 2. Now, put y is equal to 4 in equation 1. This is equation 1. So x square is equal to 4. And now you get the values of x. X is equal to plus minus 2. And now you put y is equal to 2 in the same equation 1 to get x is equal to plus minus under root 2. So the solution set is this. Basically, x is equal to plus under root 2 minus under root 2 plus 2 and minus 2. So you have four values for x, as this is an equation in x to the power 4. So let's discuss the second type of equation that can be reduced to its quadratic equation. Now, see this equation here. Now, as a rule of thumb, whenever you see an equation like this, remember that if you have an equation in basically this form, x plus a, x plus b, x plus c, x plus d is equal to any constant k. This can be reduced to a quadratic equation. but you must satisfy a condition. The condition being that if you add up any two constants in the brackets, they must be equal. So a plus b must be equal to c plus d, or for example, if you have a plus c, that must be equal to b plus d, uh, or a plus d must be equal to b plus c. I mean, any three of these conditions, if they are satisfied, then this can be converted in this entire equation can be converted into its quadratic form. But you must also remember that the x values in each of these brackets must always have 1 as its coefficient. So 1 here, 1 here, 1 here, and 1 here. If they do not, you must divide the equation by that coefficient so that the coefficient of the coefficient of x is 1. Now, see this equation here. You can clearly see that minus 1 plus 8 is equal to 5 plus 2. This is equivalent to basically this over here. Hence, the condition is being satisfied. So, what we'll do now is we'll combine this side and this side. So, x minus 1 and x plus 8, they'll be multiplied in one bracket, and x plus 5 and x plus 2, they'll be combined in one, they'll be multiplied in one bracket, and then this constant will remain as it is. Now, after basically expanding these two brackets, you get these two quadratic equations. And now, basically, you'll put x squared plus 7x is equal to y, as x squared plus 7x is common in both brackets. So this now becomes y minus 8 multiplied by y plus 10, and this constant remains as it is, minus 880. Now, when you expand that, you get this quadratic equation here. Now you solve for y by using factorization or any method that you fancy, and you get basically two values of y. Y is equal to minus 32 and y is equal to 30. Now, when you put y is equal to minus 32 and y is equal to 30 in basically, in this equation here, this equation, when you put the two values of y here, you basically get x squared plus 7x is equal to minus 32 and x squared plus 7x is equal to 30. Now, you have two quadratic equations for x. So basically you'll get four values for x. 2 over here and 2 over here. Now, by using the quadratic formula, basically what you'll get is x is equal to minus 10 or x is equal to 3. So you get four values, minus 10, 3, and you'll get two values from basically this equation here. Basically one, and they'll both be imaginary, as minus 79 here is being square rooted, and a negative number being square rooted will give an imaginary value. So you'll get two imaginary numbers over here, and that is the solution set. Let's discuss the third type of equation that can be converted to a quadratic equation to be solved, and that is the exponential equation. Over here, instead of x having powers, the terms of x will be the powers. So, see this here. This is the equation that we have. What we'll do here is basically, as you know, this becomes this 2 raised to the power 2x plus 1. This can be further simplified to 2 raised to the power 2x multiplied by 2 raised to the power 1. Now, this 2 raised to the power 1 will be multiplied with 4 to give you 8. And now look at this. This term basically here. Over here we'll take 2 raised to the power x and we'll put that whole to the power 2. And now you have terms for 2 raised to the power x over here and over here. Now, just by using your own logic as you did in the type 1 equations, what you'll do here is you'll put 2 raised to the power x equal to y. So this now becomes a quadratic equation. 8y square minus 9y plus 1 is equal to 0. Now, what you'll do here is you'll factorize this into this form, and now you'll get basically these two terms. We've discussed how to factorize an equation earlier. You can refer to that if you wish. Now, you'll get two equations for y, either y minus 1 is equal to 0 or 8y minus 1 is equal to 0. And when you solve these, you'll get two values for y. So y is equal to 1 and y is equal to 1 divided by 8. Now, put this y is equal to 1 in this equation 1. So 2 raised to the power x is equal to 1. And now this becomes 2 raised to the power x is equal to 2 raised to the power 0. So x is equal to 0. Similarly, when you put y is equal to 1 by 8 in the same equation, you get 2 raised to the power x is equal to 1 by 8. So this becomes 2 raised to the power x is equal to 1 divided by 2 raised to the power 3. And if you take 2 raised to the power 3 in the numerator, this now becomes 2 raised to the power x is equal to 2 raised to the power minus 3. And simply x is equal to minus 3. Now you have two values for x. X is equal to 0 and x is equal to minus 3. So this is the solution set. Let's solve the fourth type of equation by converting it into a quadratic equation, that is the reciprocal equation. So you have this particular equation here. What you'll do here is that you'll basically put the x to the power 4 terms on one place and the x square terms in one place, and you'll put the constant at the end. And now basically what you'll do is you'll add 2 to the x to the power 4 terms, and obviously you'll have to subtract 2 as well. And the reason you do that is because you need this term. You need these three terms. Why? Because this becomes this. And now you'll take the minus 2 on this side and you'll subtract 10 with 2 and you'll get 8 over here. And now basically these terms and these terms are same. So x square plus 1 over x square we can assume it to be equal to y. And when you plug in y in place of x square plus 1 over x square, you get a quadratic equation in y. So by factorization, we've already learned how to do that before, you get these two terms. So either y minus 4 is equal to 0 or y minus 2 is equal to 0, and upon solving this you get y is equal to 4 and y is equal to 2. So now you have two values for y, and now you'll plug in y is equal to 4 in the equation that dictated that x squared plus 1 over x squared is equal to y. Now upon doing that, basically what we've done here is we've taken the LCM. So x squared multiplied by x squared plus 1 over x squared is equal to 4. And obviously x squared will be multiplied by 4 on the other side to get 4x squared. And now by using the quadratic formula, you'll just plug in the values of a, b, and c to get this. You'll get two values for x, where one is positive and one is negative. Now, when you plug in y is equal to 2 in the same equation, you'll get this equation. You'll get this equation here. Now, this basically just turns into this. Well, how? Because if you take it as x squared whole squared minus 2x squared plus 1. Now you can see that this converts into this. Now, simply by taking the under root on both sides, you get x squared minus 1 is equal to 0 and x squared is equal to 1. So x is equal to either positive 1 or negative 1. Another way to do this is this particular equation can be written down like this. And so either x is equal to 1 or x is equal to minus 1. So now you have a solution set of x. It is either positive 1 or negative 1, or it is positive and negative of this particular value. And that's it. So let's discuss the first type of radical equation. We have discussed four types of equations that we will convert into basically quadratic equations. Now, the fifth type of equation that we'll convert into a quadratic equation to solve it is a radical equation. But we have further types in the radical equations. The first type is basically an equation like this. It only has one radical sign. A radical sign is basically this under root sign. And in the first type of radical equation that we'll discuss, it only has one under root or radical sign. And let's solve this by converting it into a quadratic equation. Now, what we'll do here is, as you know, 3x squared plus 2x is over here, and it is also over here. So what we'll do is, you'll put 3x squared plus 2x equal to y. And now you'll have this equation here. Now you'll have to take the radical term, which is this term, on one hand, and all of the other terms on the other hand. So now what you'll do is you'll take square on both sides, and that becomes this equation here. Now, by subtracting, by not subtracting, basically, you'll just do minus 14 and minus y on this hand to get minus 15y, and plus 49 plus 1, which gives you plus 50. Now, this can be factorized to give you basically these two terms, y minus 10 and y minus 5. Now, either y minus 10 is equal to 0 or y minus 5 is equal to 0, and that basically gives you two values for y. Y is equal to 10 and y is equal to 5. Now, we'll put y is equal to 10 in the equation that we made
that which was 3x squared plus 2x is equal to y. So now you'll basically solve this. Now your very first step should basically be trying to factorize the equation, but if factorization is not really possible here, then you'll go for something like the completing square method or the quadratic equation, preferably the quadratic equation method in the other cases. So this will be quite difficult to factorize. We'll just use the quadratic equation here. Now, by plugging in the values of a, b, and c, which are these, you'll get, this is quite a lengthy solution, but you'll get basically two values here. One is minus 1 plus under root 31 over 3, and the other is minus 1 minus under root 31 over 3. So these are two values. Now, when you plug in y is equal to 5 in the equation, you get this. Now this here, this is easy to factorize. So you'll just factorize the equation, and now you'll get two terms, 3x plus 5 and x minus 1. So either 3x plus 5 is equal to 0 or x minus 1 is equal to 0. And now you'll get two values for x, minus 5 over 3 and 1. Now, extraneous roots. Now in the radical equations, in all radical equations, what you must remember is that they're deceiving. So what that really means is, we found 4 solutions before. Look, this is the first, this is the second solution, this is the third solution, and this is the fourth solution. But radical equations are deceiving. Not all of these are actually solutions to the equation. Why? Because some of them are maybe extraneous roots. What that really means, and how you check for them, is basically you'll plug the same values in the equation, the original equation that you had. Now, one of the solutions was x is equal to 1. You'll plug the x is equal to 1 into the original equation given in the question, and now you'll check to see if the left hand side is equal to the right hand side. Now when you solve this, this turns out to be true, so this is not an extraneous root. Now, when you plug in another solution, x is equal to minus 5 by 3 in the same original equation that you had in the question, now you'll check again to see if the left hand side is equal to the right hand side, and then you'll solve this whole equation, and after that you'll get left hand side is equal to right hand side indeed. So this is also true. So this is not an extraneous root. Now, the third solution that we had, we'll plug that in into the same equation. Now, upon solving this turns out to be false because the left hand side is not equal to the right hand side. So basically, this particular solution is not really a solution. This is an extraneous root. This is how deceiving the reciprocal equations are. Sorry, the radical equations, not the reciprocal equations. Now, we'll plug in the fourth solution that we found in the same equation, and upon solving it, you get another false value because the left hand side is not equal to the right hand side. And so, this particular term is not a solution, it is an extraneous root. So for all radical equations, you'll have to confirm if a solution is actually a solution or if it is an extraneous root. And you'll do so just by plugging in the solutions that we found into the original equation and check if the left hand side is equal to the right hand side. And that's it. Now, we'll discuss the second type of solution of radical equation. And the second type of radical equation that we'll be discussing is something like this. So the type 2 radical equation is basically all radical terms. And in the radical terms, you'll have one variable term and one constant term. Like it is the case for all radical terms here. One variable term, one constant term, one variable term, one constant term, and one variable term and one constant term. This is the second type of radical equation. Now, how do we solve this? So, you'll take the square on both sides. Now, what have we done here exactly? On the left-hand side, how did we get this? As you know, basically, if you have a plus b whole square, it is equal to a square plus b square plus 2ab. Well, that is exactly what we have done here. Take this term as a, take this term as b, and if you whole square it, you'll get a square plus b square plus 2ab. So that's what we've done here. Now, when you open up, basically this will cut out this radical, this will cut out this radical sign, and so you'll get this and this term will remain as it is. Now, when you do all the calculations, you get this, and then basically you'll take everything besides the radical term on one hand, and you'll put the radical term on one hand. Now, you'll do all the calculations, and basically you'll get this equation. After that, you'll take this 2 in the denominator over here, and then you'll get this equation here. Now, you'll basically do the multiplication over here, and then you get this equation. Obviously, you'll do this division also, and after this, you'll take the square on both sides because you have to eradicate this radical sign over here. Upon doing so, you get this, and now you'll do all the calculations to get this quadratic equation. Now, this is easily factorable. You can factorize this equation. And always remember, in trying to solve a quadratic equation, your best bet, and because it is the easiest way to solve it, is factorization. So this can be factorized, and now you'll get two terms for x, and now either x minus 2 is equal to 0 or 3x plus 5 is equal to 0, and now you get two solutions. But remember, this is a radical equation and they're devious. So you must find the extraneous roots. It is not necessary that both of these are actually solutions. So you'd plug both values in the original equation given in the question. So let's check if x is equal to 2 is actually a solution or not. Upon putting it in the equation, you can see that the left-hand side is equal to the right-hand side. So it is indeed a solution and it is not an extraneous root. For x is equal to minus 5 by 3, when you plug it into the equation, the left-hand side is not equal to the right-hand side. So minus 5 by 3 here is an extraneous root. So you have a solution set that x is equal to 2. That is the only solution of this equation. Now, let's discuss the third type of radical equation. In the second type of radical equation, you had radical signs, you had radical terms on both sides of the equation. And in the radical signs, you had linear terms. So one basically variable term and one constant term. Over here you have similarly you have radical terms on both sides, except that under the radical signs you have quadratic terms. So naturally, your first instinct is to factorize the quadratic terms. And upon factorizing the quadratic terms, you get this equation here. Now, you can write this down like this as well. So, like two terms being multiplied under a radical sign can be written down as the two terms separately under radical signs being multiplied. So basically, this term here can be written down like this. Now, what you'll do here is you'll basically see that the x minus 1 whole under root term is common in all three terms. So, first off, you'll basically take this term on the left hand side because all radical terms must be on one side as per the rule. So you've taken the term on the right hand side to the left hand side and put a 0 on the right hand side, and now you've taken the under root x minus 1 common in all three terms to get these two terms. So this whole term is either equal to 0 or this term is equal to 0. So basically your very first solution is x minus 1 is equal to 0, so x is equal to 0. This is your first solution of the equation. Now the other solutions you must find by solving this. What is this? If you look closely, this is the second type of radical equation. Linear terms under all radical signs. So refer back to how you actually solve this. You'll take the square on both sides to eliminate the radical signs. Now, simply, if you remember, this is just like basically this term here. You'll basically solve in a way like a plus b whole square is equal to a square plus b square plus 2ab. And that is exactly what we've done here. This is a square, this is b square, and this is 2ab. Now, upon eliminating the radical signs here, you get this. And you'll take this entire set of numbers, I guess, on the right hand side because only the radical term must be on the left hand side as per the rule. Now, or as we've done here, we've taken the radical term on the right hand side. Basically, the radical term must be on one different side from everything else. Now, upon doing all the calculations, you get this equation here. You'll square both sides so as to eliminate this radical sign. So upon doing that, you get this, and then after all these calculations, you'll get this quadratic equation. Clearly, the factorization of this equation is way too difficult. So you'll just put in the quadratic formula. This 56 is A, this minus 84 is B, and this 31 is C. So after putting it in the quadratic formula and doing all the calculations, basically you'll get this. So you get two solutions here. One solution is 21 plus under root 7 over 28, and the other solution is 21 minus under root 7 over 28. So now you must check for the extraneous roots, because remember, these radical equations are deceptive and devious. So first of all, the very first solution that we found, x is equal to 1, put that in the original equation given in the question. You can clearly see that the left hand side is equal to the right hand side. So this is a solution of the equation. This is not an extraneous root. Now, the second solution that we found, which is this one here, when you plug it into the same equation given in the question, you can clearly see that the left hand side is not equal to the right hand side. So this is an extraneous root. This is not a solution. And the third solution that we found, when you plug it in the original equation, you can see that the left hand side is not equal to the right hand side. So it is also a extraneous root. It is not a solution. So the solution set is basically x is equal to 1, and that's it. That is the only solution of the equation.
Now let's discuss the fourth type of solution of radical equations. Now see this. The fourth type of radical equation we'll discuss is one in which one side of the equation has radical equations, and basically it will be all radical signs, and underneath the radical signs you'll have quadratic expressions. And on the other hand of the equation, you'll have a linear expression and no radical sign. So how will we go about this? Well, you'll give this first radical expression the value of a, and you'll give the second radical expression the value of b. Now, as you know, this is a minus b. This can be written down as a minus b, and that is equal to this, x minus 4. And we'll call this equation 1. Now, we know this. This is a very basic algebraic expression, an algebraic formula, if you will. And it basically says that a square minus b square is equal to bracket open a plus b bracket close, bracket open a minus b bracket close. So, since we know this, now what have we done here? We've used this equation and we've applied it on our original question. So, as you know, this is a, so this is now a square, and this is b square. So a square minus b square is equal to a plus b, and we know that x minus 4 is equal to a minus b over here. So this is a plus b into x minus 4. So now what you'll do is you can cancel out these radical signs as they're being squared, and then you get this. Now, once you solve this, you get x squared minus 16. And again, you'll use this particular expression here, this formula, and you'll apply it here. So x squared minus 16 can be written down as x plus 4 into x minus 4. So now, as you know, these x minus 4 terms can be cancelled out. So a plus b is equal to x plus 4, and this is now equation 2. So what you'll do here is, since we know that a minus b is equal to x minus 4, that is equation 1. So, and we have equation 2 is a plus b is equal to x plus 4. We can cancel minus b and plus b, and we can cancel minus 4 and plus 4. And you can add up these two a's and these two x's, and you'll get 2a is equal to 2x, and that means a is equal to x.
So now this quadratic term that we had originally, that was equal to x, as you remember. See this? We know that a is equal to x, so you'll use this equation here. So you'll square on both sides. This radical sign will be cancelled out. And so you'll get a quadratic equation. And by using the quadratic formula, because obviously over here it is quite difficult. Actually, it is not even possible to do factorization. So you get this. You get two values for this. X is equal to minus 7 plus under root 17 over 8 and minus 7 minus under root 17 over 8. So now you check for extraneous roots. Well, over here it is, you can actually find the extraneous roots by using the values of x that you found and putting them directly in the equation given in the question. But it's much easier if you actually use this particular expression that you found earlier over here. You need to check if this is actually equal to 0 if you apply the values of x you found. So when you do this over here, this indeed gives you 0. So we know that this term is equal to 0. And now, wherever you find this term in the original equation, you'll put 0 in its place. So this will now become 0. And this, if you just write it down like this particular part becomes 0 as well. So this is now x squared plus 0 over here. And this can be written down as 0 plus 16 because over here you replace the quadratic expression with this term here. So now this becomes, as you know, this becomes x squared and these two will cancel out, and this is just basic under root 16, and so you get x minus 4 is equal to x minus 4. So this is indeed true. And if you use the same method for the other value that you found for x, you'll find that it is not an extraneous root as well. So these are both values of x. So the solution set is indeed this. There are no extraneous roots. Now, 3 cube root of unity. What does that mean? Well, we take x is equal to cube root of 1. And if you basically take the cube on both sides. So this cube and this cube will cancel out this cube root and this will become x cube, and then you'll get this equation. And now you have to factorize it. You have to find the cube roots of unity. Well, we have to find 3 cube roots of unity. So how did you get this here? How did you factorize this? Well, you have two formulas for an equation such as this. One is a cube plus b cube is equal to a plus b into a square minus ab plus b square. And the other formula is a cube minus b cube is equal to a minus b into a square plus ab plus b square. Over here you can clearly see the negative sign, so we'll use this second formula over here. And once you apply this, you'll get this equation as a is equal to x and b is equal to 1. Now you get this equation. Now always remember that a quadratic equation is basically a quadratic expression is basically a linear expression being multiplied with a quadratic expression. So you'll always get one linear expression and one quadratic expression, just like you've done over here. Now, either this linear expression is equal to 0 or this quadratic expression is equal to 0. So either x minus 1 is equal to 0, so we get one value of x as 1, x is equal to 1, or this quadratic expression is equal to 0. And you'll find the values of x by applying the quadratic formula over here. And so you'll get this. And obviously these are two values. One is uh, one is the value of x in which this term is positive, and the other one is in the other value is the one in which this term is negative. So these are the three cube roots of unity. It is called the cube root of unity because we have 1 over here. This is the unity. So let's find the cube roots of any number, not just unity. So let's find the three cube roots of 8. That becomes basically x is equal to, in the cube roots of unity or the cube roots of 1, you put x is equal to under root 1, cube root 1. In this, you'll put x is equal to cube root 8. And now this becomes x cubed minus 8 is equal to 0. So you'll apply the same formula you did before, and you'll get basically this equation here. You know that 8 is equal to 2 to the power 3. So this can be written down like this, and then you'll apply the formula to get this equation. Now, obviously, either the linear expression is equal to 0 or the quadratic expression is equal to 0. And as you did before, x is equal to 2 and x is equal to basically this over here. So you'll get two values over here. Now, we're not done here. We'll take the 2's over here, this one and this one, common. We'll simplify this. And now you'll get this. Remember one thing. We can write this expression down as equal to omega. This can be denoted as omega. So this is omega, or this can be also written down as omega square. And that purely depends on the sign over here. The sign that we use here will determine whether it is omega or omega square. If the sign is positive, this will be omega. If the sign is negative, this will be omega square. So this can be both. So this can be either minus 2 omega or minus 2 omega square. You just need to remember this particular expression, as this is equal to either omega or omega square depending on the sign used over here. So the cube roots of 8 are minus 2 omega, and minus 2 omega square. Now, we'll find the 4/4 root of unity. We discussed previously how we could find the 3 cube root of unity. Now we'll find the 4/4 root of unity. So what that basically means is when x is equal to the 4th root of 1. Now, and the procedure here is more or less similar to how we find the cube roots of unity. So we take both sides to the power 4. So this becomes to the power 4. This becomes to the power 4, so that we can remove this 4th root sign over here. So we get x to the power 4 is equal to 1. Now we take this 1 on the other side, and now this becomes x to the power 4 minus 1 is equal to 0. So you can clearly remember that we know a formula that a square minus b square is equal to a minus b into a plus b. And that's what we've done here. This x to the power 4 can be written down as basically this entire equation can be basically be written down as x squared to the power 2 minus 1 square is equal to 0. Now we can apply this formula over here, and now we get, and then we get this. Now you can clearly see that either x squared minus 1 is equal to 0 or x squared plus 1 is equal to 0. So when x squared minus 1 is equal to 0, you get x squared is equal to 0. X squared is equal to 1. So x is either positive 1 or it is negative 1. So you get two values over here. You get two roots. Now, when x squared plus 1 is equal to 0, you get x squared is equal to minus 1. And when you take the square root on both sides, you get x is equal to either positive iota or negative iota. And remember that iota is basically under root negative 1. So the fourth root of unity are plus 1, minus 1, positive iota, and negative iota. Now, we've we'll have to find the fourth root of any number, not just unity. So find the fourth root of 16. That basically means x is equal to the fourth root of 16, which is basically equal to 16. Now, we can put, where you can take both sides to the power 4, and then as we done before, this becomes x to the power 4 is equal to 16. And again, we'll use the formula over here, this one, a square minus b square is equal to a minus b into a plus b. And clearly this can be written down as basically in this particular case, it's not really equal to. Over here we can write this down as x squared whole to the power 2 and minus 4 to the power 4, as that becomes 16. Well, that 4 to the power 2. So this becomes 16, and now this becomes equal to 0. And that's what we've done here. So now this becomes x squared minus 4 into x squared plus 4. And obviously either x squared minus 4 is equal to 0 or x squared plus 4 is equal to 0. So we have basically, we'll take the square root of both sides when we get these values. And so either x is positive 2 or negative 2, or x is equal to positive 2 iota or negative 2 iota. Hence the fourth root of 16 are two values here and two values here, positive 2, negative 2, and positive 2 iota and negative 2 iota. Now, we'll find equations whose roots are provided to us. So for example, we have a question here that if omega is a cube root of unity, form an equation whose roots are 2 omega and 2 omega square. So basically we need to find an equation in any variable, x, y, or whatever. We'll find an equation in any variable that will basically give us 2 omega and 2 omega square as its roots. Yeah, sorry for there's a bit of thunder and lightning going on outside. So let's just proceed here. So this is basically this is how you would solve an equation of such kind. This s here is basically the sum. Let me just say, the s here is basically the sum of roots, and this p here, basically the sum of roots here is 2 omega plus 2 omega square, and the p here is the product of roots, and that is basically 2 omega into 2 omega square. Now this is the sum of roots, and when you simplify it, when you take the 2 as common, you get 2 into omega square, omega plus omega square. And now look at this. This is basically something you'll have to remember. 1 plus omega square is equal to 0. Now, there is a solution, there is a proof for this, but we're not really concerned with that, so just go with it. So, when you look over here, you see that this is omega plus omega square. If you just use your head a bit, and if you take 1 to the other side over here, omega plus omega square is equal to minus 1. And so that's why we replace omega plus omega square here with minus 1. And so the sum of roots here is equal to minus 2. Now, the product of roots is 2 omega into 2 omega square, and that becomes 4 omega cube. Now, you know already that obviously omega is a cube root of unity. So, if you just take the cube of the cube root, that just becomes 1. The cube, if you take the cube of the cube root of 1, which is the cube root of unity, that becomes 1. So, this is now 4 into 1. That is equal to 4. So, now equation 1 here becomes x minus 2x plus 4, which is now equal to x plus 2x plus 4. This is the equation that will give you 2 omega and 2 omega square as its cube roots of unity. Sorry, not the cube roots of unity, but the roots of this equation are 2 omega and 2 omega square. Now, let's find real and complex roots of any equation. So like we have this equation over here. We've not really dealt with any equations that are like above quadratic or cubic equations and powers above 3 basically. So over here we have 5x to the power 5. The highest order over here is, the highest power over here is 5. So what I'll do is, this is not really difficult because if you think critically over here, if you just write this down as 5 into x raised to the power 5 minus x is equal to 0, and then this 0 over here will be divided by 5. So this now becomes x to the power 5 minus x is equal to 0. Now, you can write this down as x into x to the power 4 minus 1 is equal to 0. So either x is equal to 0 or x to the power 4 is x to the power 4 minus 1 is equal to 0. Now, this is a further simplification of this equation over here. Now, as you know, we'll apply this particular formula over here, that a square minus b square is equal to a minus b into a plus b. So once this equation is applied over here, you get this equation. Now, either x square minus 1 is equal to 0 or x square plus 1 is equal to 0. Now, upon solving it, this is basically the fourth root of unity, and we've discussed how to do that earlier. Now, x square is equal to 1, x square is equal to 1. You get x is equal to positive 1 or negative 1. Positive 1 and negative 1, not or negative 1. And if x square is equal to negative 1, you get x square is equal to positive iota or negative iota. So, you get the values of x as 0, positive 1 and negative 1, and positive iota and negative iota. So those are the 5 roots. You have 3 real roots and 2 complex roots. Now, well, at times you'll have to divide two equations. we've really discussed how to multiply equations before. Like if you had to multiply a linear equation with a, say, quadratic equation, you get a cubic equation. And that's really simple. That's just normal multiplication. But when you have to divide two polynomials, that's where things get a little bit tricky. So if you had to find, if you had to divide a cubic equation with a quadratic equation, you'll basically get a linear equation. Now, how to find that linear equation? Well, that's really where you'll have to use some theorems, and one of them is the remainder theorem. Now, over here, use the remainder theorem to find the remainder when the first polynomial is divided by the second polynomial. Now, this is the first polynomial and this is the second polynomial. So basically, you'll divide this polynomial with this polynomial. Now, what you'll do here is, this is one function of x, and now as x plus 1 is equal to 0, now this is the denominator, you'll put the denominator equal to 0, and then you'll find that the value of x here is equal to minus 1. Since this is a linear equation, there is only one value of x, and that over here is minus 1. Now, put this value of x in this equation. So, now, upon doing that, when you solve all of this, you'll see that you get a value of 5, and that is the remainder of this division that we've done. And so we found the remainder when this first polynomial is divided by this second polynomial, and that is the remainders theorem. Now let's discuss the factor theorem. We discussed the remainder theorem earlier. So the factor theorem is somewhat similar to it, I guess. So we have this question here, and this will perfectly explain what the factor theorem is. It says to use the factor theorem to determine if the first polynomial, which is this one here, is a factor of the second polynomial, which is this one here, which means that if you factorize this polynomial, the second polynomial, you'll get this x minus 1 as a factor. So how do we see this? Basically, you can write this x minus 1 is equal to 0, as you did in the remainder theorem, and you'll see that the value of x you get from this is 1. Now, you'll put that x is equal to 1 in this function of p, which we've let this as a function of p here. So when you plug in this value of x into every x over here, you'll get this, and you'll see that this equates to 0. Now, for a polynomial to be a factor of another polynomial, where you'll have to equate it to 0, and then you'll find its value, and then when you plug it in, it should give you 0, which means that the remainder is 0. And once you get that the remainder is 0, you can clearly say that the polynomial is a factor of another polynomial. So over here, x minus 1 is indeed a factor of x squared plus 4x minus 5. Now, there is another way you can check this, is if you actually factorize this polynomial over here. Once you factorize this, you'll see that the value of c here is minus 5, and the value of b here is 4. So you need to see numbers that will basically give you minus 5 upon addition, upon multiplication, and they'll give you 4 upon addition. So over here you can clearly see that if you actually 5 into minus 1, if you multiply them, it'll give you minus 5. If you add them, they will give you 4, and that's exactly what you need. So you can write this equation down as x squared plus 5x minus x. From over here, this you can use this as 5x and you can use this as minus x. So 5x minus 5. And once you factorize, you'll get x into x plus 5 and minus 1 into x plus 5. These two are common, and you'll turn them into a factor, and you'll turn these two terms into a factor. So this will become x minus 1 into x plus 5. So instead of going through all of this, you can just use this when one of the factors is given to you. And you can see that x minus 1 is indeed a factor. So this has been confirmed. Now, let's see how we can use synthetic division to factorize a polynomial and to confirm if a given factor or a given value is indeed a solution to a particular polynomial. So see over here, this question is asking us to see if this x is equal to 2 is indeed a solution of this cubic equation. So this x is equal to 2 can be written down as x minus 2 is equal to 0. So basically what we need to prove is that this x minus 2 is a factor of this cubic equation. So basically this x minus 2 will be multiplied with a certain quadratic expression. So let's see. We need to confirm, so we have two things. We need to confirm if this x is a solution, this x is equal to 2 is a solution of this polynomial, and we'll use the result of the synthetic division that we're performing to see to find out the quadratic factor that will be multiplied with this linear factor. So how we'll do this? You see, we have this value of x given. So you'll write that down over here. Now, you see these numbers, these four numbers, they're the coefficients of the terms in the cubic equation. And as you can see, the coefficient of x cubed is 1, this one here. And there is no x square term over here. So the coefficient of x squared will be 0. The coefficient of x is minus 7, and the last constant is 6. So what you'll do is you'll write down this 1 as it is down over here. Now you'll multiply this 2 with this 1, and then you'll put the result down under the next number, which is 0. So you'll write down 2 under 0. And now you'll add this 0 and 2. That will give you this 2 over here. Now you'll multiply this 2 again with this 2. And now you write down the result under the next number, which is minus 7. So 2 into 2 is 4. You'll write that down over here. And now you'll add minus 7 and 4. That gives you this minus 3. Now again, you'll continue to do this again and again, as many times as you have to, until you reach the last constant. So we'll multiply this 2 with this minus 3. That'll give you minus 6. We'll write down minus 6 under the last value over here. So 6 plus minus 6, which is basically 6 minus 6, that will give you 0. And that is the last value that you'll receive is the remainder. If the remainder is equal to 0, that means that this basically the solution that we've been given is indeed a solution of this polynomial. So since the remainder is 0, that means that x is equal to 2 is indeed a solution of x cubed minus 7x plus 6 is equal to 0. So what that really means is, so x is equal to 2 is a solution of this. And it also means that x minus 2 is a factor of p of x. But you're wondering how will we find the quadratic expression that x minus 2 is being multiplied with to give you this cubic equation? Well, You see these three values, this 1, this 2, and this minus 3? Well, these are the coefficients of the quadratic expression that x minus 2 is being multiplied with. So 1, the coefficient of x squared, 2, the coefficient of x, and minus 3, the last constant. So you have this as the second factor of this cubic equation. And upon further factorization, you can clearly see it gives you two more factors. So you can see what this means is this cubic expression over here, x cubed minus 7x plus 6 given in the question, can be factorized down into these three linear expressions. And that's it. This is how you do synthetic division. Now, finding unknowns when roots are given. Well, you'll not really be given easy questions for synthetic division, and one of those questions is something like this. Basically, what this says is you've been given this cubic expression, and these a and b, you have to find out their values. And the only information that's been given to us is that minus 2 and 2 are the roots of this polynomial, which means that upon synthetic division, two times obviously, once with minus 2 and once with 2, the remainders of those synthetic divisions will be equal to 0. Now, basically x minus 2, x is equal to minus 2, and x is equal to 2. So x plus 2 is equal to 0, and x minus 2 is equal to 0. So what this means is that x plus 2 and x minus 2 are factors of this cubic expression. Now let's go down to the synthetic division. So we'll let this cubic expression be a function of p, and we've been given these two solutions. So we've already discussed before how we do synthetic division, but just for reminder's sake, let me explain it again. You write down this, any one of these basically. You can choose any of these roots that have been provided to you. First, we'll do you'll perform synthetic division twice, as you've been given two roots. So we have this x, we have this minus 2. We'll write it down over here, and then you'll write down these four terms. These four terms are the coefficients of this cubic expression. 1 is the coefficient of x cubed, minus 4 is the coefficient of x squared, a is the coefficient of x, and b is the last constant. So what you'll do is first you'll write down this 1 as it is. You'll multiply this minus 2 with this 1. The result, which is minus 2, will be written down underneath the next number, which is minus 4. Now, you'll add up minus 4 and minus 2. That will give you minus 6. You'll multiply this minus 2 with this minus 6. And then the result, which is 12, will be written down underneath the next number, a. And then you'll add a and 12. So that will give you a plus 12. You'll multiply this minus 2 with this a plus 12 again. And that'll give you basically this minus 2a minus 24. And you write down minus 2a minus 24 underneath the last constant, which is b. And once you add them up, they will give you the remainder. And minus 2 plus b minus 24 is basically the remainder. Now, obviously, you'll ignore the remainder and you look at the coefficients. These three coefficients over here. Now, these three coefficients are basically, just this down over here, they're basically the coefficients of the quadratic term that x plus 2 over here is being multiplied with. So this basically gives you x plus 2, and over here you'll be writing down the quadratic expression, which is 1 is the coefficient of x squared, so x squared, minus 6 is the coefficient of x, so minus 6x, and this is the constant, a plus 12. So this will become plus a plus 12. This is the quadratic expression. Now, this x minus 2 over here, this is a factor of this quadratic expression, obviously. So you write down this 2 over here, and obviously you'll perform synthetic division again. So this one will be written down as it is. Then 2 will be multiplied with it. The result underneath this minus 6. This minus 6 will be added with 2. So this will give you minus 4. This minus 2, this is 2 will be multiplied with minus 4. That will give you minus 8. And that will be written down underneath the last constant, which is this a plus 12. So upon adding a plus 12 minus 8, you get this a plus 4. A plus 12 under minus 8, and then you get this a plus 4 as the remainder. Now, since minus 2 and 2 are confirmed roots of the polynomial, that means that the remainders that are provided to these two remainders are both equal to 0. So, we'll write down both is equal to 0. So, you'll get this value of a as minus 4 when you put a plus 4 is equal to 0. And then you'll plug in the value of a, which is minus 4, into this second equation. And upon doing that, you'll find the value of b, which is 16. So you have found the values of a and b. And hence, you've solved the question. Now, we'll find values using roots of a given equation. So the roots will be given to us, and we have to find basically different values. So alpha and beta are the roots of this quadratic equation. And we have to find 1 over alpha square plus 1 over beta square. How you do that? Well, you must remember these two equations. You must always remember them. So alpha plus beta is equal to minus b over a, and alpha beta is equal to c over a. What are a, b, and c, you ask? Just like in the quadratic formula, they are the coefficients of the terms in the quadratic equation. So the coefficient of x squared is a, the coefficient of x is b, and the last constant is c. So in this particular case, alpha plus beta is equal to b is equal to minus b over a, which gives you 2 over 3, and alpha beta is equal to c over a, which is 4 over 3. Now, you have to find the values of 1 over alpha square plus 1 over beta square. You'll perform the LCM over here, and that will give you this expression. Now, remember that we've discussed the most basic quadratic identities, so the most basic algebraic identities, that x plus y whole square is equal to x square plus y square plus 2xy. So x plus y whole square minus 2xy is equal to x square plus y square. And you'll basically use this logic over here in the numerator. And upon doing that, you'll clearly see that alpha square plus beta square is equal to alpha plus beta whole square minus 2 alpha beta. Just like over here, x square plus y square is equal to x plus y whole square minus 2xy. So you get this in the numerator, and the denominator, you can clearly see that alpha square into beta square can be written down as alpha beta whole square. Now you will replace this alpha plus beta with 2 over 3, this alpha beta with 4 over 3, and this alpha beta with 4 over 3 as well. And then you basically get this. And after doing all the multiplication and calculations, you'll basically come down to this. And upon further simplification, you'll see that the value of 1 over alpha square plus 1 over beta square is equal to minus 5 by 4. So you solve the question. Now, we need to find an equation whose rational roots are given. Well, if alpha and beta are roots of this quadratic equation over here, form the equation whose roots are 1 minus alpha over 1 plus alpha and 1 minus beta over 1 plus beta. Now, Before we do anything, remember that a quadratic expression can be written down like this: 1 minus sy plus y minus sy plus p is equal to 0. S is the sum of roots. Sorry, this is y square. Y square minus sy plus p is equal to 0. And s is the sum of roots, and this p is the product of roots. Now, we'll proceed further. We'll use these two formulas as we've done before. You must remember them at all costs. So, alpha plus beta can be written down as minus 3 over 1, as the value of b is minus 3 and the value of a is 1, this 1. And alpha beta can be written down as c over a, which is this 5 over 1. So we have values of alpha plus beta as 3 and alpha beta as 5. Now the roots of the equation are 1 minus alpha over 1 plus alpha and 1 minus beta over 1 plus beta. So we first find this sum of roots. So 1 minus alpha over 1 plus alpha plus 1 minus beta over 1 plus beta. Now, after performing the LCM, you get this term. Now, upon further multiplications and further simplifications, obviously over here, you'll cancel out this plus beta and minus beta, you'll cancel out this minus alpha and plus alpha, you'll cancel out basically that's it actually. So you'll add up this one and this one, and you'll add up this minus alpha beta and this minus alpha beta to get 2 minus 2 alpha beta. And in the denominator, this just becomes basically 1 plus alpha plus beta plus alpha beta. Now replace this alpha beta with this 5, this alpha beta with this 5 as well, and this alpha plus beta with this 3. And so you get this. And upon further calculations, this is what it comes down to, minus 8 over 9. So the sum of roots is minus 8 over 9. Now we find this p, the product of roots. So you'll multiply these two and you'll get this term over here. Upon further multiplication and calculation, you'll see that it comes down to this. Now, this can be written down like this as well. So you'll now basically replace this alpha plus beta with 3, this alpha beta with 5, this alpha beta with 5, and this alpha plus beta with 3. And you get this. Now, upon further calculation and simplification, this is what it comes down to. The product of roots is equal to 1 over 3. Now, as you remember, the way to find the quadratic equation is y square is equal to minus sy plus p. We found s and y. So this is basically the quadratic equation. And to give it a more formal look, you'll just multiply each term with 9, and that'll give you this. This is the final quadratic equation of the roots that were given to us, which were which is 1 minus a over 1 plus a, and 1 over alpha minus 1 minus alpha over 1 plus alpha, sorry, and 1 minus beta over 1 plus beta. So you solve the question. Now we must find the nature of the roots of a quadratic equation. Now, you remember that this quadratic formula, everyone remembers this at this point? Well, we're concerned with this part, this plus minus under root b square minus 4ac. This part is what will give you two values for x. One will be positive and one will be negative. So the nature of those roots will depend on b square minus 4ac, this term, and it will be called a discriminant. So from now on, we'll refer to b square minus 4ac as the discriminant. So in the first case, if the discriminant is equal to 0, then the roots will obviously be minus b over 2a, since this entire portion becomes 0, and you're left with this b square minus b over 2a. So the roots will be minus b over 2a twice. They will be repeated. This minus b over 2a will be repeated as a quadratic equation has two roots. So the roots over here will be real, as obviously 0 is a real number. This entire portion will give you a real number, and they will also be repeated, and they will be equal. They will be equal because b square minus 4ac is equal to 0. They will be real because minus b over 2a is obviously a real number. Now, in case 2, the discriminant is less than 0. So the under root b square minus 4ac will be imaginary, as b square minus 4ac is a negative number, less than 0. So the roots are complex or imaginary, and they will be distinct and unequal. They will be distinct and unequal because this is not equal. So b square minus 4ac is not equal to 0. And they will be complex and imaginary because the discriminant is less than 0. Similarly, in the third case, well, not similarly, but the concept is similar. This b square minus 4ac, the discriminant, is greater than 0. So the under root b square minus 4ac will be real, as b square minus 4ac is a positive number greater than 0. So the roots are real and distinct and unequal. Why are they distinct and unequal? Because it is not equal to 0. The discriminant is not equal to 0. And what you must also remember is that if b square minus 4ac is a perfect square, then this under root b square minus 4ac will be rational, otherwise it will be irrational. The roots will be rational if this b square minus 4ac is a perfect square, otherwise irrational. So let's just say we're given an equation like this one here, x square plus 4x plus 2 is equal to 0. Now, b square minus 4ac, we have to find the nature of the roots of this particular equation. So b square minus 4ac is equal to 4 square minus 4 into 1 into 2, which becomes 16 minus 8, which is equal to 8. 8 is not a perfect square of any number. So if you do under root 8, it will just become under root 8. It's not a perfect square of any number. So the roots of this equation, the roots are, well, under root 8 is a positive number. So b square minus 4ac is basically b square minus 4ac is equal to under root 8, which is basically greater than 0. So the roots are real. This is case 3. They are real, they are unequal or distinct, and lastly, they are irrational, as under root 8, as basically 8 is not a perfect square. So that's how you do it. Now, for what value of an unknown will the roots be equal? So we have this question. For what value of m will the root of the following equation be equal? This equation. So we have to find the values of m for which the roots of this entire equation will be equal. Now remember that for the roots to be equal, this b square minus 4ac must be equal to 0. Now, over here, you can see that a is equal to m plus 1, b is equal to 2 into m plus 3, and c is equal to m plus 8. Now, the roots of the given equation will be equal if b square minus 4ac is equal to 0. So, we'll calculate b square minus 4ac, and after doing calculations, basically you'll get this over here. Minus 3m plus 1 is equal to 0. Now, minus 3m is equal to minus 1, and this gives you that m is equal to 1 by 3. Now, this is the value of m for which the root of this equation is equal. And some of you might be asking, well, aren't there really two roots to a quadratic equation? You must remember that this is the first case of the nature of roots, and what this means is that if b square minus 4ac is equal to 0, the roots will be equal, but they will also be repeated, which means that this value of m is there's just one value of m, and the roots are basically just they repeated. There's just one root and it's repeated twice. That's it. Now let's discuss the solution of a system of equations. So over here we have a question, and it says that we have these two equations, and by using these two equations we must find the values of x and y. So how do we do this? Basically, now we're dealing with two variables, and once you have two variables, you need two equations to solve them. So let's see. Over here, you'll give this equation the name equation 1, and this is now the second equation, and now you'll basically just give this variable y this value. You'll take 2x, you'll take 4 on this side, and you'll take y on that side, and now you have an equation for y, a function of x, if you will. Now, put this equation 2 in equation 1, and now replace every y in equation 1 with 2x minus 4. Now, upon solving it, you'll multiply 4x with everything inside this bracket, and then you'll square 2x minus 4 over here. And after performing all these calculations and simplifying, you'll basically get this. And then once you take minus 2 common outside, you get this equation. And now you'll take minus 2 on the other side. You'll divide 0 by minus 2. And then you'll get this equation. Now, you'll factorize this equation, and upon factorization, you'll get this equation. Obviously, over here, this 5x minus 11 and this 5x minus 11 will become one factor, and x minus 1 will become the other factor. Now, either 5x minus 11 is equal to 0 or x minus 1 is equal to 0, or both of them are 0. Basically, you'll equate both of these factors to 0, and now you'll find two values for x, 11 over 5 and 1. Now, you have to put these values of x in equation 2. Just a reminder, this is equation 2. y is equal to 2x minus 4. Now, put x is equal to 11 in y is equal to 2x minus 4, and upon solving it, you'll get a value y is equal to 2 over 5. And then you basically have this solution set x when x is 11 over 5, y is 2 over 5. And similarly, for x is equal to 1, you'll put that into y is equal to 2x minus 4, and upon solving it, you'll get this solution set. When x is equal to 1, y is equal to minus 2. And now you have this solution set, this complete solution set, where you have these two. Now, let's solve a solution. Let's find the solution of one linear and one fractional equation. So like last time, we have a system of equations in two variables, but over here we have one linear equation and one fractional equation. Before this, we had one linear equation and one quadratic equation. So let's see. So basically, this is your linear equation and this is your fractional equation. Now obviously x cannot be 0 and y cannot be 0. Why? Because when we have zeros in the denominators here, they'll give you a value of infinity, or they're not defined really. So we cannot have x and y have value 0. So we'll give this fractional equation the name equation 1, and we'll look at the second equation. We'll basically write this in terms of y. So basically y will now become a function of x, which is y is equal to 5 minus x. Now, put y is equal to 5 minus x in equation 1, this fractional equation. So replace every y in this equation with 5 minus x. Now, we have this equation, and you'll take the LCM. So you'll multiply 2 with 5 minus x. So you'll get this. And then you'll multiply 3 with this x, so you'll get this 3x, and in the denominator you'll have x into 5 minus x. Obviously everyone knows how to find the LCM. It's not really that hard. Now you'll take this denominator and you'll multiply it with this 2 on the right hand side. Now, upon further calculations, you'll get this quadratic equation. Now, once you factorize this quadratic equation, you'll get basically, you'll take this will become one factor, 2x minus 5 will become one factor, and x minus 2 will become the other factor. So you'll have this factorized form of the quadratic equation. And so either this 2x minus 5 is equal to 0, or this x minus 2 is equal to 0, or both of them can be 0. So we'll equate both of these factors to 0 to get two values for x. And those two values are 5 over 2 and 2. Now, we'll put these values in equation 2. And just a reminder, what was really equation 2? Let's just see. This was equation 2, y is equal to 5 minus x. So, we'll put these values of x in y is equal to 5 minus x. Now, upon putting x is equal to 5 minus 2, you'll get a value of y, 5 over 2. So you'll have this as a part of the solution set. When x is 5 over 2, y is 5 over 2. Now, when x is equal to 2 and you plug that into the equation, you get a value of y, 3. Y is equal to 3. So the solution is when x is equal to 2, y is equal to 3. And the complete solution set is this. So now we'll make a linear equation to solve two quadratic equations given to us. two simultaneous quadratic equations. So we have a system of equations here. We have this equation and we have this equation. Now, we have to make one of them linear to actually be able to solve for x and y. Now, we'll give this equation the name equation 1, and we'll now use this equation and we'll basically expand it. So we'll basically expand x plus 3 whole square over here and y minus 1 whole square over here, and we get this equation as a result. And now we'll do some calculations, subtract and add and everything like that, and in the end we get this equation over here. Now we'll give this the name equation 2. So we'll basically now solve them simultaneously. We'll subtract equation 1 from equation 2. Now over here basically you'll subtract x square and x square, you'll subtract y square and y square, and then basically as a result you'll get 6x minus 2x, you'll get 4x over here, you'll get minus 2y minus 0 minus 2y, and over here you'll get minus 5 minus 9, so minus 14. Now you have this whole equation, 4x minus 2y is equal to minus 14, and you can basically take 2 common outside, so you'll get this equation. Now you'll divide minus 14 by this 2 over here, and now you have basically this equation, and now you'll actually have an equation in y over here. So y is equal to 2x plus 7. This is equation 3. Now put the value of y from equation 3 in equation 1. So basically we found equation 1 earlier, the second equation given in the question, and you'll replace y with 2x plus 7 from equation 3. Now once you expand this and do all the calculations, you get this quadratic equation over here. Take 5 common outside and then divide 0 by 5, and so you'll get this quadratic equation. Now you'll factorize this quadratic equation, and so you'll get this two factors, x plus 4 and x plus 2. And now either x plus 4 can be 0 or x plus 2 can be 0, or both of them can be 0. So now you'll equate x plus 4 to 0 and x plus 2 to 0 to get two values for x. And you get x is equal to minus 4 and x is equal to minus 2. Now you'll put these values in equation 3. So when you put x is equal to minus 4, the first value of x in equation 3, you get y is equal to 2 minus 4 plus 7, and you get a value for y which is minus 1. Now when you put y, okay, now this is the first part of the solution set. So when x is equal to minus 4, y is equal to minus 1. Now when x is equal to minus 2 and you put that into equation 3, you get a value of y is equal to 3, and so you'll get a set over here. So when x is equal to minus 2, y is equal to 3, and this is your solution set. This is the first set and this is the second set. Now we'll find a solution of a system of equations containing only x square and y square terms. So you have this equation and this equation. Now basically what you'll have to do is, you see this equation over here, the first one, you'll basically have to put the x square and y square terms on the left hand side and the constant, which is the 6, on the right hand side. So basically this becomes 2x square minus 3y square is equal to 6. This is your first equation, equation number 1, and the second equation is already given in its correct format, so this is equation number 2. Now what you'll have to do is you'll multiply equation 1 by 3 and equation 2 by 2. Why, do you ask? So that the coefficients of x square become 6. See this? The coefficients of x squared are now 6. Now you can somewhat solve them simultaneously. So what you'll do is, basically, you'll subtract. So 6 subtract 6 squared, and this becomes minus 6 squared. So this cancels out. This minus 10y squared becomes plus 10y squared because this minus sign is multiplied with a minus sign since it's being subtracted. So this now becomes y squared. Oops. Yeah. This now becomes minus 9y squared plus 10y squared. So this becomes y squared over here. And this becomes 18 minus 14, and that becomes 4. Now, y squared is equal to 4. Y is equal to positive 2 and negative 2. Obviously, because under root 4 is equal to positive 2 and negative 2. Now, you have two values for y over here. So, first of all, you put y is equal to positive 2 in equation 1. Just to refresh what equation 1 is, this is equation 1. You put the value of y is equal to positive 2 over here. So, when you do that, you get this, and now basically upon further calculations, you'll get two values for x, positive 3 and negative 3. So you have this as a solution, and this has two solutions basically. One is with positive 3 as the value of x, and one is with negative 3 as the value of x. The value of y is 2, obviously, because you took that as the first step. You put the value of y is equal to 2. Now, in the second one, you'll put the value of y is equal to minus 2, the second value you found over here. And you'll put that in the same equation number 1. When you do that, and upon calculation, you'll get two more values for x, positive 3 and negative 3 again. So, you now have two more values. One is this, and one is this. Now, the solution set will have 4 values. Now, we'll find the solution of a system of equations involving xy terms. So, you have this basic quadratic equation with two variables, and you have this xy term in it. And this is a simple quadratic equation in x squared and y squared. Now, this xy term is what makes this interesting. Now, the solution, as with every equation we've discussed so far, the solution is not really difficult, but over here it's a bit lengthy, so bear with me. So you have these two equations. You'll basically split this minus 5xy into minus 3xy minus 2xy, and now you can actually factorize this entire equation. So what you'll basically do is you'll factorize this equation by the same method that you used for a normal quadratic equation in one variable. So see over here, this is 6. You'll basically use this as your C, and this is minus 5. So basically you'll have to find two values that when multiplied will give you 6, and when added up they'll give you minus 5. So over here, obviously, look at this, minus 3 multiplied by minus 2, that gives you 6, and minus 3 plus minus 2, that gives you minus 5. So that's what we've done over here. And upon factorization, this is one factor, x minus 3y, and the second factor is x minus 2y. So this is now factorized. So either x minus 3y, this is 3y, x minus 3y is equal to 0, or x minus 2y is equal to 0, or both of them are 0. So we equate them to equal to 0. And so first you'll solve this linear equation. Now you get two linear equations over here. So you'll have to do further calculation. This is why this question is lengthy. So x minus 3y is equal to 0. Now we have this equation, x squared minus y squared is equal to 45 given in the question. Now from equation 1, which is this x minus 3y is equal to 0, you can get x is equal to 3y by taking minus 3y to the other side. Now put this value in equation 2, and so you replace the value, you replace x with 3y, and so you get this equation, and by further calculations you'll get two values for y, positive 3 over under root 2 and negative 3 over under root 2. So you have two values for y. So you'll first put the positive value in equation number 3. So when you put the values in equation number 3, you get this. Remember, equation number 3 was x is equal to 3y. And so now you get this solution. So when when x is equal to 3 over under root 2, you get the value of x as 9 over under root 2. Now, when you put y is equal to negative 3 over under root 2 and put that in equation 3, you get this solution. The value of x is negative 9 over under root 2. This is the solution. Now, look at this. We had two linear equations that we found. We already did it for one linear equation. Now we have to look at the second linear equation. And now, when you put the second linear equation, you get, in terms of x, you get 2y. X is equal to 2y. Now, when you put that into equation number 5 over here, which is basically equation number 3, I guess. So when you put the value of x in equation number 5, which is this one, you get this equation, and upon solving it, you get two values for y, plus positive 3 and negative 3. Now, first you solve for positive 3. When you put the value of y is equal to positive 3 in equation number 5 or equation number 3, they're the same thing. You get x is equal to 2y, which is 3 over here, and so you have a value of x is equal to 6, and this is the solution. Now for y is equal to negative 3, you proceed with the same method, and you get the value of x as negative 6, and you get this as the solution. Now you have 4 solutions in the solution set, 2 from the first linear equation and 2 from the second linear equation, and that's it.